Hello. Hello, Kinza. Okay. Bhumi, am I audible to you clearly?
Yes, sir.
Okay, fine. So we know the. Give me 1 minute. We know the Coulomb's law. We know the Coulomb's law. Uh, mm, Coulomb's
Yes,
law.
sir.
We know the Coulomb's law. I have told you in the first class. 2 point charges. These are 2 point charges. Q, Q1 and Q2. These charges are separated by a distance r, and the force of interaction, the force, you can say force, is given by k q1 q2 divided by r,
R square.
r square. This is the formula, and the value of k is given by 1 upon 4 pi epsilon naught 0 if these charges are placed in it. Okay, so this was the Coulomb's law, and the value of this is
9
uh,
into 10 to the power
yeah,
9.
yeah. But today we will study this Coulomb's law in vector form, because why we are studying this, because uh, the question has already asked in the CBSE examination. Okay, okay, fine. So but before that, you should know about the position vector and displacement vector. Position vector and displacement vector. Position vector. Position, position, the word position and the word vector. This is y-axis, this is x-axis, okay, and this is origin, origin, O-R-I-G-I-N, O-R-I. Origin means the reference point. So position vector means, like, suppose uh, if I am saying here is a point, this is the position of point, this is the position of point with respect to x and y axis. I am supposing a point, simple.
Yes.
I am not saying anything. I am saying that this is a point here. with respect to x-axis and y-axis. This is the x-axis, this is origin, and this is. And now, now if the distance of this point from the, this is the point, and the distance of this point from the origin is suppose r1. This is r, this is 1, r1, and suppose this is a point A. This is point A, this is origin, and the distance between origin and point A is r1.
Yes.
So now this is the position with respect to origin of this point A. Now if I will do this, means this is the vector position of point A. Fine now?
Yes, sir.
Okay. And if I am taking another point, like I am taking a point here, I am taking a point here, and I am measuring the distance from the origin, and the distance from the origin to this point is R2, R2, and this is point B, this is point D, and this is a vector R2, means R2 is the vector position of point to B, vector position of point B.
Yes.
Okay, very good. So this is very simple. So I can write here, I can write R1 vector, comma, R2 vector are position vectors. Position vectors. You can use the name when you learn this. Position vector. Earlier it was position, and now this is vector. Position R1, R2 are the position vector of point. This is the point of point A and B. You can say A comma B. So this is the position vector. Okay. Do you have any doubt in this? Okay.
No, sir.
Okay, fine. So that's how we represent the position vector. Position. Now, okay. So this is about the position vector. Now, what is displacement vector? Displacement. Displacement vector. So you can think this. from the name, displacement and vector. Displacement and vector. Okay. Now let's see if this is the position vector of A, this is the position vector of B. If someone wants to move from this point to this point, like
A to B.
yeah, A to B.
Then that vector will be known as displacement vector.
Yeah. Means someone is moving from A to B and actually this is from this tip, okay?
Yes, sir.
Actually I cannot make it like okay, so fine. Mm, so AB vector is displacement vector. AB vector is displacement vector. So this AB vector is represented like in the vector form like R, this is R, and I am moving from vector R1 to vector 2 means I am writing this R12 vector. Okay. So R, this is R, this is 1, 2. This is not pi. Pi is like all okay now. This is not pi. So this is R12 and R12 is equal to displacement vector from R1. R1 is a position vector. R1 to R2. Okay. So this is displacement. Displacement vector means you are moving a certain distance. Okay, you are moving a certain distance, and that distance in the vector form is known as
Displacement vector.
nothing is special here. What is this? Okay, so this is the displacement vector, and if uh, I want to write, mm, R12. R12, if I want to write, then I can write R1 vector minus of R2 vector. Please remember this point. So, okay. Bhumi, if someone is moving from point B to A, if someone is moving from point B to A, if someone can move from A to B, so he or she can also move from B to A?
From B to A, it will be vector R21.
Very good. Very good. Very good. R21. So how should I write this? R2.
R2 minus vector R2 minus vector R1.
Very good. Okay. And R21 will be called as displacement vector from R2 to R1. So I am writing here. I am writing here. R21 is displacement vector. Displacement vector from R1 position, R2 position vector to from R2 position vector. This is R2 position vector to R1 position vector. Simple, simple. Okay, now you can write it down and please make proper notes. Okay, that will help you very much. Okay, now you can note it down.
Sure, I wrote this one already.
You have written this.
Yeah, while you were writing, like after. Yeah, this one after it.
You have to write. Actually, I will give you an advice. Like when you should write, because you have to make the notes. That is very important. But when I am teaching or I am telling you some concept, then at that time, uh, please try to understand, try to relate it. Okay, you should
Yes,
try
sir.
to relate the concept, because we have mind and we have focus in some directions, like this, like this, like this. Okay, right now I am here, but I am also thinking that after this class I am having another class, and after that I have to go to somewhere for, okay, with someone. Okay, I am thinking that this is I am thinking. But because when the person is at a point of time, okay, so he or she may have a number of thoughts already, and when I am teaching to you, this is a nature, this is a nature, we cannot change this, this is from the God or Allah, we can say. But we should try to focus our energy, we should try to focus our energy. Okay, and when I am teaching, uh, please try to relate the things, please try to relate the things, please try to understand what I want to say, what I want to say, what I am telling. And if you will write continuously, like, okay, so like I am making a diagram, I am making this diagram, and you are writing continuously. Sometimes you should write accordingly. If the topic is easy, so you can write with me, no problem. But when I am teaching, I am saying this is a vector A, this is a vector B, this is a vector R. You should relate that. Okay, so that will be, I think, beneficial for you. Otherwise, as you want, you like. Okay, so now you should note it down. Don't hurry up in writing the things. In writing the things, I will give you the time, as much as time as required. Okay, so Bhumi, have you understood what I have told you? Have you understood? Hello? Hello? Am I audible, Bhumi?
Hello, yes, sir. I got
Uh,
disconnected.
so, uh, few seconds later, I have told you a story. Have you understood?
Yes, sir.
Okay. Have you noted down this?
Yes, sir.
Okay. Completely till here?
Yeah.
Okay. Okay. So, this is the position vector. Position vector represents the position of a point. Position of a point. And displacement vector is the displacement when we are moving from a position to another position. So now we will start the Coulomb's law in vector form. Coulomb's law in vector form. Means we have to write the Coulomb's law in the vector form. The vector. So for this, I require two axes, and I am taking this as y-axis and this as x-axis. This is y-axis. And suppose here is one charge. Here is 1 point charge. Here is 1 point charge. Okay. With respect to this axis, and here is here is another point charge. Here is another point charge, and this is 1 point charge, and this is another point charge with respect to these axes, and this is origin. This is origin, and the position of these point charges with respect to origin this is a point charge, and the with respect to origin this is a point charge is r1. This is the position vector of this point charge, and similarly I can take this is the position vector r2 of point charge, and these point charges are some distance apart. These point charges are some distance apart. And this is the charge q1. Here is the charge q1, and here is the charge q2, and this is position, so I am supposing as a. This is the position at. Nothing has changed here. Means this system is also a system. We can say two charges separated by some distance, and now this some distance I can write this distance as r12 vector Bhumi, because we are moving from A to B. This distance is A to B. Okay, this distance is the distance from moving A to B. Means now these 2 point charges are separated by this distance, but I have written this distance in the vector form. I have written this distance in the vector form. And if I am supposing these charges are positive charges, so I can say that the direction of force will be in this direction. Okay, I can do it like this. Okay. Okay, there is some force of interaction, and the direction of the force of interaction in this direction, this is force. And what I will call this force, this is a force on B due to A, force on B due to A, and this is a force on A due to B. This is a force on A due to B. Okay. Okay, fine. This is the point. Okay. So what I have done, I have taken 2 point charges, but this time taken with the vectors. Taken with the vectors. Taken with the vectors. Just now what is R12? We have discussed that R12 vector. R12 is a vector, means we can say the position vector, displacement vector. This is displacement vector. Okay, and now we have a vector, and I have told you that we can also calculate the magnitude of vector. Magnitude of vector, I have told you now. So if I
Yes.
want to, yeah, if
You
I
add
want
it.
to, yeah, magnitude. If I want to calculate the magnitude of R12, then I will write it as magnitude as R12 vector and mod. This is the magnitude of this vector. Magnitude of R12 vector. Okay. We have discussed this thing. You should remember this. Okay. Now it's fine. Magnitude means simply the distance. Simple the distance. Magnitude is like simple distance. Now I can say the distance. Am I audible?
Yes,
Okay.
sir.
Okay, fine. So I can simply say that the distance between 2 point charges is this. I have taken the magnitude of this. Okay. So now if I want to calculate FVA, FVA. Okay. Now if I want to calculate FVA, so we know that K Q1 Q2 divided by K Q1 Q2 divided by this square. Okay, the square of this. This is the distance simply. This is a simple distance. So I can write this as the square of R12, and this is magnitude vector, and the square of this. Is it fine? Is it fine now? So FBA is, I have done nothing. I have just apply the formula K Q1 Q2 divided by the distance square. Now this time the distance is written in this form. So I have written the distance in this form. Okay. But there is another thing we have discussed, the unit vector. We have discussed another thing, unit vector. Okay. So now there will be use of unit vector here. Okay. Use of unit vector here. If I want vector, this is now only the magnitude of the force VA. If I want to convert this force into the vector, what will I do? If I want to write this FBA in the form of vector, what I will do? This is the magnitude of this. I will write the magnitude simply R12 vector mod square, and I will multiply this with the unit position vector. The unit position vector. Oh, okay, I will multiply this with the unit position vector. Okay, and I have told you about the unit vector. We have discussed about the unit vector. Let's see. Bhumi, are you getting my points, or just these points are getting out of your head?
No, sir, I remember unit vectors, universal unit vectors.
Very good. Where I have discussed. If you want to convert a scalar into a vector, you should multiply that scalar with the unit vector. So where I have written, I don't know. Actually, we have not. Okay, no problem. I think. Okay, so unit vector is the hmm, having the magnitude 1. Unit vector is having the magnitude 1. Now if I want to calculate r12, I have told you for the unit vector we use cap. So this unit vector can be written as r12 divided by magnitude of r12. This is the unit vector. That's how we write the unit vector. Okay, I have converted this force into vector.
Yes, sir.
Okay. So I can put this value here. So FBA, you can write KQ1 Q2 divided by R12 square, and I can multiply this with this R12 vector. This is R12 and this is magnitude. So simply from here you can write FBA is equal to KQ1 Q2 Q1 Q2 divided by, this will become cube of this, because when we multiply a square with this will become R12, and this is vector, and this is the cube of this, and I can write here R12. Okay, I can write here R12. So this is the Coulomb's law in vector form. This is the Coulomb's law in vector form. And I have already told you that I can write R12. How can I write R12? R1 vector minus R2 vector. R2 vector I can write now.
Yes, sir.
And for this vector I can also write R1 vector minus R2
R2 vector.
vector and the cube of this. And the cube of this. So this is the Coulomb's law in vector form. This is the Coulomb's law in vector form. Okay. Coulomb's law in vector form. And here the main thing is this. Here what I have done, now I am telling you, but you should not note this, but you should see on the screen very carefully. Okay, Bhumi? Okay, fine.
Yes, sir.
Suppose we have a force of 5 Newton. We have a force of 5 Newton, and we have a unit vector of this force, unit vector in this direction of force as I can say have unit vector represented like this is 3 I cap. And if I want to write this f in the vector form, So I will write first the magnitude of force F and multiply this with the unit vector. Okay, this is that's how we write the unit vector. So I can write 5 multiplied by 3 I cap. So the force in the vector can be written as 15 of I cap. So F vector can be written as, okay, F, this is the unit vector in the direction of this. Same the case here. This is the unit vector in the direction of force. Force is in this direction, and this, if we take the unit vector of this, the direction of that unit vector will be in this direction. So simply I multiply the magnitude with the unit vector. Okay. Okay, Bhumi. So please note it down.
Yes, sir.
Noted already?
No, sir. I'm writing it
Oh,
now.
okay, please note it down. Bhumi, do you know Hindi?
Yes, sir.
Okay. You are from India?
Yes, sir.
Okay. In India, you are from where?
Sir, Rajasthan.
Okay. Okay, fine. Please note it down. So the Coulomb's law is just uh, the Coulomb's law. You can say the vector form of Coulomb's law is just a game of vectors only. Means you have seen that we should have a good decent understanding of vectors if we are studying the electrostatics. That's why I have told you that time the unit vector, because I knew that I will use this in this uh, Coulomb's law in vector form and in many other places. Okay. Should I scroll down? Have you completed this?
Yes, sir. I completed now.
Okay, fine. Okay. You can ask me to scroll down if you complete.
So you can scroll.
Okay, okay. Fine.
Yes, sir.
Okay. Okay. So now we will calculate F force on charge at A due to charge at B. And I am writing one thing more here for your, that will be easy for you. You can write here you can write unit vector in direction of, you can write here unit vector in the direction of FBA. FBA. BA. Okay. R12 is the unit vector in the direction of FBA. Okay. Hmm, okay. Completed, Bhumi?
Yes, sir.
Okay. So now I am calculating F. I have calculated FVA. We know what is FVA. This is FVA. Now
Yes.
I am calculating FAB. I am calculating FAB. So for FAB, F, if I want to calculate FAB vector, okay, okay, fine. FAB. So FAB is equal to again K Q1 Q2 divided by, but this time you have to take R21. Why R21? Because we have to take the vector in this direction. Okay, no problem. I am just doing some different thing. Calculate FBA. FBA vector. If you want to calculate FBA vector, then first you have to write the magnitude of F, not FBA. This time we are calculating FAB. Okay, not FBA. Okay, FAB. Okay, I am calculating FAB vector. I have told you I want to calculate FAB vector. For that, I need the magnitude of FAB. For that, I need the magnitude of FAB and the position vector, unit position vector in the direction of. So you can say the direction of position vector will be now R21 because the direction is like this. Okay, direction is like this. Earlier the we have taken R1 to 2 because the direction of force is like this. Now we will take R2 to 1 because the direction is in this direction. So unit vector of R21 and FAB, if you will calculate FAB, you can simply write KQ1 and Q2 divided by, you can write the distance between them, R12. R12 is the distance, magnitude of distance. Actually, R12 vector is equal to R21 vector. If we are talking for Azan, I will stop. Okay, so these are the R12 is equal to R21. Magnitude of R12 is equal to
Magnitude of
R21.
R21.
So
Yes.
these are nothing but the distance between two charges, point charges. Distance between charges Q1, Q2. So I can write here R21 also. R21, and this is the distance, and we take KQ1, Q2 divided by distance square. And now we will multiply. I have multiplied with this also. So for this I can write R21 vector. This, instead of this unit vector, I can write R21 vector and the magnitude of R21. We have done this actually. Actually, the thing is that you can write any unit vector, like this is the unit vector. The unit vector of force can be written as force vector into magnitude of force vector. Similarly, if you are writing the unit vector of this, you will write the vector of this divided by the magnitude of vector of this. So from here, I can write k q1 q2 and divided by this will become cube of this r21 cube. This is r, this is 21, and this is vector, and this will become cube, and here we have the vector r21. Okay, vector r21. So we can write it as k q1 q2. What can I write for r21? Can I write r2 minus r1 minus r1 and the cube? And for this, I can write r2 vector minus r1 vector. We have discussed this, and this is the force AB. So, okay, fine. So this is the another thing. Nothing has changed, but the vectors are changed. Means here r21, the formula is same. You can see here k q1 q2, k q1 q2. Instead of this, you are from B to A. If you want to calculate FBA, for BA, you will use R1 minus R2 cube and multiply with R1 vector minus R2 vector. Here, if you want to calculate FAB, then you will write K Q1 Q2 R2
Cube.
minus R1 cube and
Cube. Yes.
multiply with. See here, this and this are same, looking same.
Yes, sir.
Cube of this and you multiply the vector with is same. So you can note it down. Okay, so this is all about the Coulomb's law in the vector form. Vector form means you are writing the force in the vector form.
Yes.
Okay, noted. You can note. And note it down. And after that, we will have one question and last question. This is should we complete the question today in today's class, or if you want to complete the question in the next class?
Yes, sir.
Do you want to? I am having one question on this Coulomb's law. Okay, so I am saying
So
that
yes. So is it big? Like, is
what?
it like lengthy?
No, lengthy, not lengthy, but I want that. I think this is enough for you for today. If I will teach you more than enough, then okay. We have discussed the position vector,
Displacement
displacement,
vector
and
and
vector,
Coulomb's
and
law in vector
in
form.
vector form. I have used all these things now. I have used all these things in the Coulomb's law. I have used all these things in Coulomb's law.
Yes.
We can modify it uh, if we consider this as position one. Okay, no problem. You can, but If I am modifying this now, then the formula will be very easy for you. I am modifying it. So I am writing this as position 1 instead of A. This is position 2 instead of. So this will become F21. Please write it down again, because this will be easy for you. F21, and instead of A or B, I am just
F12.
F12. Now you will see what will happen. F12. Okay, this is F12. You should modify this. Okay, I am instead of A and B. Okay, yeah. Actually, I am having a class. So from instead of BA, instead
Yes,
of,
sir, I know. It's you just have to. I just have to change that.
you
I
have to
did.
write two.
Yes,
You
sir, I
have to
wrote
write 2 1.
2-1 and the next is 1-2. I wrote it, sir.
Okay. Hmm, 1 minute. You are writing 2. Okay. Are you okay with this?
Yes, sir.
So you can
Yes,
do
sir.
you can do this now. Are you sure?
Yes,
Accordingly,
sir.
you can change. Instead of FAB, you will write F12. Instead of FBA, you will write F21.
1-2.
Okay,
Yes.
so Bhumi, now you can leave, and now I am having another class. Okay, and if you have any doubt, please ask me.
Yes, sir. Thank you, sir.
And okay, thank you. Hello,
Yeah. Hello, sir.
hello, how are you?
I'm fine, sir. Thank you.
Okay, so mm, hmm. So in the last class, you were absent in the last class.